Well, this is a very interesting question. So we have the limit as x approaches infinity of x to the power of x of minus x plus 1 over x. I'm thinking what we can do is like split it. You can make it x to the minus x times x to the 1 over x, and do the limit as both of those go to infinity. And we can transform it like this: x to the 1 over x over x to the x. And we do the limit of that as it goes to infinity. Am I right? Yeah, I'm right. Okay, so what we can do is I could do squeeze firm. I could say this is of course bigger than 1 over x to the x. So then x to the 1 over x to the x, and this is greater than I'll say x over x to the x for all. This is how you write all, by the way, mathematically. For all x values greater than 1. And then you both do the limit as it goes to infinity. This, of course, will approach 1 over infinity, which is just 0. We still have this to worry about. Limit as x approaches infinity of x to the x over to the x. Yeah, x to the x. Fuck, a lot of x's. What can you do for this one is, since they're both going to infinity, it's just equal to infinity over infinity, and you can apply L'Hopital's rule, which states that if you have a limit as x approaches some constant of f of x over g of x, gives off the value infinity over infinity or 0 over 0, you can do the derivative of the top and the bottom to get maybe a value. So that's what we could do. We could do the derivative of the top and the bottom. What's the derivative of x is 1. With respect to x is 1. Derivative of x to the x, you could do implicit differentiation, which I want to do actually, because I have the time to. So make y equals to x to the x, do ln on both sides, ln of y is equal to x to the ln of y because of the log property, but you can drop down the base. Do implicit differentiation, you do d over dx over d over dx, and then you do chain rule. What chain rule makes it 1 over y, and you still have that y thing, y prime, which is just dy, dx, and derivative of that is just 1 ln of x plus, it turns into 1 over x, 1 over x times 1 over x is just 1, it's just that, and you move it to the other side, so you get x to the x bracket ln of x plus 1. And that's our derivative of x to the x. And as you just realized, the ln makes the function grow slightly faster. Even though this is a notoriously slow function, especially when the 1 plus 1 plus 1, it makes it bigger. It makes it like twice as bigger. It's just x to the x ln of x plus itself, which of course, if you do 1 over that behemoth, that thing, of course you get infinity, and that will be 0. So where we now left off is the is 0 is greater than x to the power of 1 over x over x to the x is less than 0. What's the number between 0 and 0? There is none. Then it has to be 0 itself. Then this, as the limit as x approaches infinity of x to the power of minus x plus 1 over x is equal to 0.